Let's talk about some periodic trends, meaning patterns that happen across the periodic table. The first one is atomic radius. That means the size of the atom, so like literally how big it is. For example, a bowling ball has a bigger radius than a ping pong ball. So if we look at the periodic table, we can sort of eyeball which ones are going to be bigger, which ones are going to be smaller. As we move down the periodic table, they're going to get bigger because the atoms just have more stuff. The ones at the bottom have more protons, more neutrons, more electrons, so they're just going to be bigger as you go down. But how about right and left? It turns out that the ones on the left side are actually bigger because they have fewer valence electrons. For example, francium, all the way here on the bottom left, I'm going to circle it. Francium is huge because it's a big atom to begin with. It's got 87 protons and neutrons, but it only has one valence electron. So that one electron can kind of do whatever it wants. It's just hanging out. And then the atoms get a little bit smaller as you go up here, a little bit smaller, and a little bit smaller, a little bit smaller. Until you get up here in the fluorine neon area, these guys are really, really tiny. And the reason is they have so many valence electrons. They have, if you're fluorine, you have 7. If you're neon, you have 8. And all those valence electrons are so negative that they stick to the nucleus. If you have a bunch of negatives in the cloud, they're going to stick to the nucleus and make a really, really tiny, compact atom. So that's why those are the smallest. Let me erase these strokes here. The next one is electronegativity. That is how badly an atom wants to gain an electron. So check it out. If you are one of these guys over here, if you're lithium or you're beryllium, what do you want to do to be happy? Do you want to gain electrons to go all the way over here into the happy row? No, that would take too much energy. You want to lose an electron. You want to lose your electrons so that you can sneak around the back and go into group 8. But think about atoms over here, like fluorine. Fluorine is so close to being happy, he just needs one more. If he can get one more electron, then he'll be happy. So he really, 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 really wants an electron. Oxygen, he wants an electron. Well, he wants 2 actually. He needs 2 more electrons to be happy. Nitrogen needs 3 more to be happy. Carbon could either gain 4 to be happy or it could lose 4 and go around the back way. So if you think about it, the ones that are closer to being closer to group 8, they want them the most. They really, really, really want one more electron to be happy. So we say that they are more electronegative. So electronegativity, increases as you go across here. It gets bigger and bigger and bigger as you go to the right because they want that electron so badly. And it also increases as you go up. As you go up, it increases. So we have a general trend, a general diagonal trend like this, where if you're hanging out down here, you don't really care. You don't really want an electron that badly. But if you're up here at the very top, you really, really want one more electron. So those are the most electronegative. Notice that it's the opposite of the atomic radius trend. All right, let's go to our third and final one. That would be ionization energy. Remember what an ion is. An ion is an atom that has lost or gained an electron. The ionization energy is the energy required to take away an electron. Energy required to take away an electron. So, check it out. Which atoms want to lose an electron? This guy wants to lose an electron, lithium. If he loses one electron, he'll be really happy. So it's really easy to take it away. If you take away lithium's electron, it's really, really easy because that's what lithium wants to do. It wants to lose an electron, so it's really easy to take it away. It's pretty easy to take away beryllium's electron because it also wants to lose him. And it's a little bit harder to take away boron's electron. How about fluorine? Fluorine wants to gain an electron. It doesn't want to lose an electron. It wants one more. So it's really, really hard to take it away. Imagine being fluorine. You just need one more electron to be happy. That's all you need. And then someone comes along to take it away? No way. You're not going to give it up. So the ionization energy increases as you go across here. It gets bigger and bigger and bigger, meaning it's harder and harder and harder to take it away. It requires a ton of energy to take away the electrons of the elements over here on the right because they don't want to give it up. But if you go over here to the left, it's really easy to take them away because they do want to give it up. And it also increases going up here. So it's the same trend as electronegativity. Ionization and electronegativity have the same trend where it's low down here, and it gets bigger and bigger and bigger, and then it's biggest up here. Okay? I hope that helps.